Welcome back to our Table Talk lessons. We are now continuing with our examples of mechanics, and the example is under our topic of Newton's law of motion. Please, it is very important at least to be remembering the laws. However much it may not be asked like state word like in physics, but basically it is a very good idea for you at least to state the first law that a body always continue in its state of rest or uniform motion unless acted. It helps you so much in analyzing questions because there are ideas you pick from there that if a body is at rest, what then is very true? Some kind of equilibrium. So follow our video, my video behind there, and then see what is very true with that statement. And then number two, the second law that is stating that the rate of change of momentum is directly proportional to the force applied and always takes place in the direction of the applied force. And we see that whenever a force is applied on the body, there are a number of things it does. But as per now, we're looking at it. The main thing that it can do is it changes the state of the body. If it is moving, it can make it come to rest. Or if it was at rest, it make it moving, okay? And now we have numbers of examples that we should do and see how best can we really analyze using that. Because under that second law, we derived our formula that will help us for some good time in mechanics. That is F equaling to MA, where my F here is the resultant force. We look at this one as always resultant force. And then the mass of the body and acceleration caused by the force to bring out what you're calling accelerating force. So let's see how this can help us where we are heading. And here with us is now an example, and it is saying that if a force of this 10I plus 2J and the AI plus BJ acts on a body of mass 500 kilograms. So that means that you are given in your idea, they have given you a mass of 500 G, and that is the same as 0.5 kilograms, because you're going to divide by 1,000. The unit should be in its standard. Okay? That is what actually happens. So we shall have that as our mass. And now we can say, what is our resultant force? Our resultant force is supposed to be 10I plus 2J. Okay? I put that wiggle there. And then plus AI plus BJ. So this one we can write it as 10 plus A into I, and then plus 2 plus B into J. Okay? And this is our resultant force. So we can say using resultant force equaling to MOA. Okay? Here I added the terms with the I on them. Here there is I, here there is I. I add them together and then I give them one single I. And then J, I add them together and I give them J. So, if I'm to use that, I'm going to say, I can decide to write this one horizontally like this. 10 plus A. That is in case you are trying to avoid what? That is in case you are trying to avoid writing the I and J. You can write this one in columnar format, okay? There, even if now you don't put the I and J, but if you write it horizontally, we are supposed to put the I and the J, okay? And then I can now say this is 0.5 into my A is this value here that I can now that I've decided to write it in columnar way. I can now write everything like that. Clear? You can look at that, and then I can say 10 plus a is equivalent to multiply that by that, you'll get there your 12, and then this is 10 plus a, and then 2 plus b. I write all of them at once, and then I can now say that times that would be 1.5, if I'm not mistaken. Please feel free to pick your calculator and you press this. Just feel free. 0.5 times that. Remember, 0.5 is a half, so it is like a half of 24, and that is 12, and then a half of 3, that is 1.5. Now from here, the next thing is equating that. I'm still continuing with this. The next thing here is equating in terms, equating components. The I and J components, I can equate them. The upper one should be equal to the upper one, lower one to the lower one. So for I components, you can say 10 plus A is equaling to 12, and then A is 12 minus 10, or you can decide to go live and say your A is equivalent to what? To 2. And then you can also equate, this is for I component, and then you can also talk about for J component. For J component, I can now say this is equivalent to that, and then 2 plus B is equivalent to 1.5, and then you can say B equaling to 1.5 minus 2, and that is giving us B as equaling to negative 0.5 or a half, or this is negative a half. And now after getting that, you can make your conclusion that therefore the value of A and B are let me just conclude like this. The value of A is equaling to 2 and B equaling to whichever value you want there, negative 2, and this is your final answer. So that is how you can basically play with this kind of problem, and that is a simple one. Let's now meet for some other better examples.